Good morning, everyone. Am I audible to you?
Yes, sir.
Okay, thank you. Okay, everyone, is there anyone have any doubt regarding the previous classes? Today we are going to start a new one, new topic. So before that, if anyone have any doubt, you can ask me. Okay, then let's start this class. Can anyone tell me where we stop in the last class? Did you discuss this numerical? Please respond yes or no. Okay, this numerical did we discuss? Okay, what about this? This did we discuss this one? This one we have already discussed, is it? Okay, then one is left, I think. In section D, I have discussed this also. So let's continue from this. Okay, let's first of all finish this numerical, then we'll go to the next topic. Okay, so here you see, are you all able to see this? Am I, my screen is visible to you? Okay, fine. Thank you. Let's go discuss this. Okay. See, whatever we already did, we discussed about the numerical types as in which where only the point loads is there. Okay, only the point loads are there. Like here, as you can see here, this point loads 40, 60, 80. When we discussed in the previous numericals, only these point loads are there, or only this UDL are there. Okay, excuse me. Only point loads or the UDLs are there. But in this numerical, what we did, we have to both point load and UDL. Okay, so the procedure will be the same. Only we need to add as per the loading system, which load affect which portion of the beam. Okay, so what is our aim? So using ILD, we need to determine the shear force and bending moment at C in SSB shown in the figure. C means this point, C point, this point. At this point C, we need to find out the shear force and bending moment as per the ILD. Okay, SSB means simply supported beam, as all of you know. Okay, so the system is same. What we need to do, first of all, we need to find out the shear force. Then we need to find out the bending moment. After that, we need to find out the coordinates as per the loading. Okay, so let's go step by step. Okay, what is our first step? First step is our always maximum shear force. Okay, so all of you already know what is the formula to finding out the maximum shear force at a point C. In our case, we are considering that point C. Okay, so for that FC, we are written FC means shear force at that point C, and all of you already know there is two formula to finding out that shear force in that particular point. One is L minus Z by L, and one is minus Z by L. So L, all of you know what is the distance, total distance, this all length is 2, 2, 2, 2, 2, and 4, 6, 8, 10, 12, and 14. So total length is over 14. Z. Z is what? Z is the distance where the point C is there. So as you can see, C is at a distance of 4 meter from the support A. If you consider this as A, and this was as B. So from A, it at a distance 4. So L minus Z by L, we can easily find out the values. Okay. Similarly, minus Z by L, we can easily find out the value. So first part is our over. Okay. Next, what we need to do, we need to find out the bending moment. Just give me a second. Okay. The meeting is locked. Fine. So next is bending moment. So again, we know the formula. Bending moment, for bending moment, this is the formula. At that point C, when we need to find out the bending moment, this is our formula. MC is equal to Z into L minus Z by L. Everything we know. Just what we need to do, we need to put the all the values. Okay, just put all the values Z, L, and all these things. From that, you can easily find out the bending moment. Okay, so our first part is over. We have already calculated the shear force and bending moment. Now what we need to do? We need to do. We need to find out the ordinate as per the load. Okay. As you can see, there are how many loads? 1, 2, 3, 4. So due to this 4 load, 4 ordinate will come. For your reference, if you consider this figure, you see there are 4 coordinates: y1, y2, y3, and y4. So all of you already know how we need to find out this coordinate. We need to consider the similar angle triangle condition. As first, if we consider this triangle, if I draw this, okay, so something will like this will come out, and one ordinate will be here, this y1. Okay, if we further divided in this triangle, so there will be two triangle in between. Okay, so from that, if we consider the similar equal triangle formula, is simply consider all the values. I think we already know these values, this line values, these values, and these values we already know because we have already found out that FC. Okay, let me show you this. This is our L minus Z by L, and this is minus Z by L. We know these two values. Now we need to find out this Y1, Y2, Y3, and Y4. So simply we can find out Y1 by this minus Z by L by the length. Okay. So by using this, you can easily find out this one. Oh, sorry, not this one, this one. You can easily find out this Y1. Okay. Similarly, you have to find out the Y2, Y3, and Y4. Okay. Is there anyone have any doubt in this? You can ask me. Okay. Just go through this once and ask me if you have feel any doubt, any confusion, how you need to find out. I think I have already explained you how you need to find out the ordinate in the previous numerical. Here in the previous numericals, we have already discussed about this, how we need to find out These things I have already discussed how you need to consider these things. This by considering this, how you can find out this y1. Okay, so same thing you should apply here also. Okay, in case of this numerical also. So anyone have any doubt up to this? Okay, fine. Then similarly, what we need to do, we need to find out the y1 dash, y2 dash, y3 dash, and y4 dash also. Okay, and remember the numerical will be same. Okay, sorry, not the numerical, not the diagram will be same. You will get a diagram only like this. Okay, this type of diagram only you will get this. Okay, so your basic diagram will be same. Here you see this y1, y2, y3, y4. We have already calculated. So now we can say what is the value of this y1, y2, y3, and y4. Okay. As per that, in this figure, you put the values. Okay. L minus z also you know, minus z by l also you know, y1, y2, y3, y4 also you know. Okay. Similarly, when you draw the ILD for maximum bending moment, you will get a diagram like this. Okay, so for in this diagram also y1 dash, y2 dash, y3 dash, and y4 dash you need to find out by this way, this y1 dash, y2 dash, y3 dash, and y4 dash by using the similar angle triangles condition. Okay, so after finding out this, what we need to do now, we need to find out the shear force at that particular point C by all the loads. Okay, what is the effect of all the loads in that particular point, because we are finding out at a particular point. Because see, when we consider ILD, it's basically what it is, a moving load. We are considering for a moving load. So if we consider a particular point, and we if we need to find out in that particular point what is the effect of all the loads, then we should go through this. Okay, so we need to follow these steps how to find out. You can consider the point into anywhere of the beam. Okay, it's not like that you need to consider the points as I did in the 4 meter distance. You can also consider that point into a 5 meter distance, 3 meters distance, 6 meter distance, anywhere. Okay, just not consider the point in that particular where the load is given. Okay, other than that, you can anywhere of the beam you can consider that point, and you can check this procedure again. Okay, by considering that point in somewhere else also. Okay, what is the effect of that all the loads in that particular point. So now as we are considering a point C at a distance 4, so we are going to find out SF at that point C. Okay, so for that what we need to do, as you know the formula, what is the formula for finding out the SF? It's already given, W into Y. Simple formula is W into Y if there is a single point load. But in our case there is 3 point load and one UDL is given. So for more than 1 point load, what is our formula? It is formula is W1 into Y1 plus W2 Y2 plus W3 Y3 plus so on. Okay, as much load is given we can move on. But in this case also UDL is there. So for that part, as we know what we need to consider, we need to consider area of that beam where the UDL is applied. So in our case, as you can see in the question, you see there is a UDL is given from the point load 1 up to a distance 4. Okay, so this is our W2, and in this area we need to consider this area for the UDL. Okay, others we can simply multiply W into Y, but for this UDL as we did here you see area we are considering because there is a UDL is given. Okay, for UDL, here what is the formula? It is given here. You see W into area of the shaded portion in the ILD for FC, and simply W into area of the shaded portion in ILD for MC. As in this numerical, both the conditions are there, point and UDL load. So we need to consider the both. So for that, see for the first load, we just consider W into Y1. Y minus sign is there because it is in the below portion. This y1 you see, this y1 is in below side, others in the above side, so it will all plus. Okay, so Here you see what we need to do. First, for first part, w into y1, sign is as per the pattern. Next, for w2 into what we did, we need to consider this area. You see, minus a1 plus a2, because there are two areas here, and the below this one, below this shaded portion, this one, and this one. If you consider this is a1 and the above one is a2, so we need to take that also here. We need to consider this, and the other rest is simple w3 into y3, w4 into y4. So y1, y2, y3, y4 already we have calculated. Okay, fine. For a1 and a2, as you, I have already discussed with you how we need to find out. We need to consider the trapezium formula for finding out the area of the particular area. So for trapezium, all of you, I think all of you know how to find out the area. Just put the values and find out the areas and put everything in here. Just put all these things and you can easily find out the value. Okay, is it clear to you? Are we able to get it? Is it clear up to this point? Okay, fine. Thank you. All of you, please do it. Okay, try to do by your own. Don't just don't read and keep it like this. Try to solve by your own once, then you can easily find out. If there is any confusion, you please ask me. Okay, next, similarly, what we need to do, we need to find out the bending moment at section C. Here also, as you already know, we need to use the formula here, w into y1 dash plus w2 into, in the second part, as there is UDL is given, we need to consider a1 dash plus a2 dash, and other all are same, w3 into y3 dash plus w4 into y4 dash. Okay, as you can already find out this y1, y2, y3, y4 dash. Now again a1 and a dash, a2 dash same. You need to find out this area and this area by using trapezium. Okay, and one thing you remember, when you calculated the y1, y2, y2, y4, you should use this diagram. Okay, and when you use y1 dash, y2 dash, y3 dash, and y4 dash, you use this diagram. Okay, excuse me. So after finding out all these things, you just put all the values here again, and after finding out all the value, you can easily find out the bending moment at that point what we were going to get. Okay, just put all the values and find out the value. Here you see it is showing how we have find out this y1 dash, this y1 dash, y2, y3, y4 dash, all are showing here. How we need to find out these things are showing here. Okay, just try to do by your own once, because all the values we already know, all the length and all these things we know. Just we need to put the values and find out. Okay, this is the same thing. Set at C as a bending function. This is a repetition. Same thing. Okay. So after finding out all these things, what we need to do, we need to draw this diagram. Okay. First of all, we can't say what is our values. Okay. After finding out all the value, you can easily now say what is our L minus Z by L minus Z by L. This y1, y2, y3, y4, here also y1 dash, y2 dash, y3 dash, y4 dash, everything you can say. And this middle line also you can say, as you can find out that MC, this value also you can say. So this is the simple numerical. Everything you can easily find out. Just follow the steps and try to do it once by your own. Okay, you can sense the values also. You just try to sensing this value, replace this value by someone else. 20 like 40 60, this 10 kilonewton by 20 kilonewton, this distance by 4 to 4, anything you can sense, try to do. Okay, is it clear to you this numerical? If there is any doubt you can ask me. Okay, anyone have any doubt you can please feel free to ask me up to this. Okay, up to this if you have any doubt. Is there anyone have any doubt? Yeah, all of you do one thing. You put your attendance in the chat box and also go through the numerical once. I am marking your attendance. Till then, if you feel any doubt, if you want to ask anything, you can ask. Okay, just go through once through the numerical. Is there anyone left to give the attendance? Please don't give twice. Okay, in wrong I meant. Please don't give twice. Just once is enough. Okay, is there anyone have any doubt? You can ask. or else we will not start because this meeting will not last long. So we'll start the next topic in the next class. Are you all able to follow what we are discussing till now? Okay, then fine. We'll start the next class at 10:15 to 20. Okay, all of you please join in the next class. Thank you all.